Hello everyone, in today's video we're going to be taking a look at another aspect of polymorphism, and that is method overloading. Now our Java fans, when you see overloading, you go, yay, overloading, yes, we can use that, we can finally do that in Python. No, we can't overload directly in Python, but we can fake it. Let me show you what I mean here. So what I'm going to do is I'm going to create myself a class. I'm going to call it math stuff. Very, very specific, I know. And what I'm going to do inside this math stuff class is I'm going to go ahead and get myself a static method here. And I'm going to make it just do some addition. So I'll do def add A and B. It's the only thing we need. And we'll keep it nice and simple here. We'll just return A plus B. Super duper simple like that. Now, let's go down here. Let's go ahead and create ourselves. We'll go ahead and use that. We're using a static method today, so I don't have to create an object. But let's just do it. Print math stuff. We're going to do A plus B, so 63 and 1 should work pretty well. Let's go ahead and run that real quick. And we can see we get a big nasty increment here because I did math stuff dot add psi. Let's go ahead and run that real quick. And of course, we get our lucky number there, 64. Now, this is where problem starts. You're sitting here going, this is pretty cool, but you know what I miss? I do a lot of Java. So, I'm going to make an add that does 3. So you come in here, you type in def add, you do a, whoa, I don't need add here. Actually, this is a static method again. Ew, static method, gross. So you come in here and you do add again, you do a, oh, I don't even need add. A plus B and C here, fantastic. So you come in here and return A plus B plus C, and you're like, yeah, look at that. We got ourselves a really, really solid little, we only call in there. So you've got yourself a really, really handy little thing here. You say, aha, so if the user gives us 2 parameters, we're going to go ahead and return the sum of those 2. If they give us 3 parameters, we're going to go ahead and return the sum of those. So you're like, I like that. So how would that work? So you come in here, you come down here, you do print stuff. Math stuff, again, this is very, very silly, but it works well. Plus add, and we come in here and we'd say 2 plus, let's see, 2 plus 60. That looks pretty good to me. You come in here and you go ahead and run, and Python will explode. The reason Python exploded is because of the fact, if you take a look at my class up here, you probably have observed the fact that my AB here is being overwritten. This entire function replaces this function. As a matter of fact, I'm kind of surprised it's not screaming at me right now saying, did you intend to, oh, there it is, redeclared add without above usage. And it's basically not working. So you're sitting here going, oh, that's kind of a pain in the butt. I can't just have it start differently if I have different requirements? No, this isn't Java. We don't do that here. But the good news is there is a way we can actually make this work. So if you need to take a look at it, I'll let you take a look at it because I'm about to delete it. Got to delete it. Actually, even better. Let's go ahead and comment it out just in case you want to take a look at it later. So what I'm going to do now is I'm going to do that again, and I'm going to do it the Python way. So let's go ahead and get ourselves class math stuff. And this time what I'm going to do is get my static method. Yeah, it looks pretty good to me. And we're going to do it a little differently. Def add. And I'm going to send 3 different values here, but I'm going to use default values. Watch this. A equals 0, B equals 0, C equals 0. So now I'm going to simply return A plus B plus C. See how I'm cheating? Watch this. So now if I come down here, let's go ahead and call it print math stuff. What a silly name for this. This is so much work for like not having to be this much work, but whatever. And we'll send a value of 2 and 62. Let's go ahead and do a run. Oh, it worked perfectly. Yes, indeed. Let's go ahead and do that one more time here. Mathstuff.add. We'll do 2. We'll do, let's see, we'll do 4 minus 2 and 62. I'll keep it nice and simple there. Let's go ahead and run it again. Bam, look at that. Now you're sitting here going, what? How did you do that? Well, one of the cool things we have in Python is the ability to basically feed it default parameters. Now, you'll notice here, because I left the C parameter out, it automatically defaulted to having itself as a value of 0. Now, if you're quick, you would immediately say, okay, that's fine and all, but that works for this. What would you do if you did multiplication? Because obviously if you add 1 plus 1 plus 0, it's going to be 2. You don't have to worry about it. But if you did multiplication, if you did 1 times 1, which would be 1 times 0, you'd get 0. That doesn't work. You can't fix this. You lose. Nice try. Well, we can get around that too. So let's go ahead and create a new one called multiply. And we'll do the same exact, got to make it a static method. Did I mention I don't like static methods? It feels so dirty doing static methods. So we'll go ahead and do A equals 0. We'll do B equals 0. And we'll do C equals 0. Now, very, very sharp-minded people immediately say, can't you just set C to 1? Because if you multiply 1 by anything, it doesn't affect its values. Shh, we're doing it the hard way. So what I'm going to do is I'm actually going to change this to a variable type of none. Now, a none variable basically tells Python that it doesn't have a value. So if I send something, I get nothing. I don't even have an integer there. It's literally a no value. So then we'd have to do something like this. We'd have to say if C. Now your brain goes, what? If C, of course, we'd have to set this to be if C equals none, rather. But the cool thing with none is because of the way it's configured in Python is we don't actually have to do anything. We can simply say if C. Now the problem is, though, is I'm saying if C equals true. That doesn't make sense in this context. What I'm really saying here is I'm saying if C is none. Now, if I say if C is none, I can simply come in here and I can now make a decision. If C is none, all we have to do is return A times B. Now, the opposite, of course, is if C is not none, we simply return A times B times C. Now, you'll notice here that PyCharm's a little grumpy at me. The reason it's like, why are you doing none with an equality operator? The reason it's doing there is because it's basically saying there's a better way to do it. And of course, you could come here and say not. You could say if not none. The other thing you could do here is you could say, actually, that makes no sense. It'd be if not C, rather. You're saying if not C, and return A times B. This looks a little goofy if you ask me, but it's Python. It's Python. And of course, if we come down here, if it's not C, which simply means that we have no value, return A times B. Otherwise, return A times B times C. So now if we were to come down here and say math stuff, just like that, times multiply this time. If we do 2 and 2, for example, I'll go ahead and give that a run. That should give us a value of 4. Now, if we wanted to, we could come in here and do 2, 2, and of course, give us a value here and do 2. So it's going to be 2 to the third. You got yourself 8. So you can see here that in a way we overloaded our methods, but we didn't really overload our methods. We basically worked around the problem of overloading methods. Now keep in mind, we did this with static methods, so we didn't have to use static methods here. We could have done traditional methods, but for the purposes of this, I thought it was very important that you kind of see how you can kind of reach in there and kind of do those things. It's also a good review of static methods, which, as I've joked before, it's like, really? But sometimes you need a purpose. Enjoy.